Welcome to the Bare Metal Cyber CISSP Prepcast. This series helps you prepare for the ISC Squared CISSP exam with focused explanations and practical context. In this episode, we're diving into architecture layers, specifically the OSI model, the system layer, and the application layer. These layered frameworks are essential for designing, managing, and securing complex information systems. Understanding how each layer functions and what security controls apply at each stage is key to building effective cybersecurity strategies. Architecture layers simplify complexity. They help break down large systems into manageable components. Whether you're analyzing a data breach, securing a network, or troubleshooting a system failure, layered models allow you to focus on one piece at a time without losing sight of the broader structure. Let's begin with a high-level understanding of what architecture layers are and why they matter. At their core, architecture layers represent a structured approach to system and network design. Each layer has a defined role, scope, and set of responsibilities. This segmentation allows for targeted controls, clearer accountability, and more efficient problem-solving. In cybersecurity, this layered thinking enables a principle called defense in depth, where multiple layers of security are applied to prevent and mitigate threats. If one layer is compromised, the next layer still provides protection. When controls are deployed at each layer of the architecture, threats are less likely to succeed, and responses become faster and more precise. Architecture layering also improves visibility. It allows analysts to identify exactly where an issue occurred, what systems are affected, and which controls failed. It supports compliance management, where auditors need to see that protections are implemented from the lowest system layers to the highest application interface. With that foundation, let's look at one of the most widely taught and used models in cybersecurity, the OSI model. OSI stands for Open Systems Interconnection, and it provides a standardized framework for how data moves across a network. The OSI model breaks down network communication into 7 distinct layers. From the bottom up, these layers are physical, data link, network, transport, session, presentation, and application. Let's go through them briefly. Layer 1, the physical layer, deals with the actual transmission of raw bits over a medium, like cables, switches, or wireless signals. Security at this layer includes physical access controls, secure cabling, and shielding against tampering. Layer 2, the data link layer, handles node-to-node data transfer and error detection. This includes Ethernet, MAC addresses, and protocols like ARP. Security here includes port security, MAC filtering, and switch hardening. Layer 3 is the network layer. It manages logical addressing and routing, primarily through IP addressing and routing protocols. Firewalls and routers operate at this layer. Security controls here include IP filtering, network segmentation, and VPN tunnels. Layer 4 is the transport layer. It ensures reliable transmission through protocols like TCP and UDP. Security at this layer includes secure port configurations, denial of service mitigation, and session control. Layer 5 is the session layer. It manages sessions between applications. While less visible in practical security, it can include token-based session controls and secure login states. Layer 6, the presentation layer, is responsible for data formatting and encryption. It translates between data formats and manages how information is encoded. TLS encryption operates here, along with certificate validation and secure encoding practices. Layer 7 is the application layer, the top layer. It includes protocols like HTTP, FTP, SMTP, and user-facing applications. Security controls include input validation, strong authentication, API security, and web application firewalls. Understanding the OSI model helps you pinpoint exactly where a vulnerability or misconfiguration lies. It guides you in applying the right control at the right level and improves your ability to communicate clearly about network issues across teams. Let's now move to the system layer. This layer refers to the underlying platforms that support applications and user environments. specifically hardware, operating systems, system services, and middleware. The system layer is foundational. If it is compromised, everything that runs on top of it is at risk. This is where system-level threats like kernel exploits, privilege escalation, unpatched vulnerabilities, and misconfigurations exist. Securing the system layer begins with system hardening. This involves removing unnecessary services, closing unused ports, enforcing secure configuration baselines, and ensuring that operating systems are updated with the latest patches. Access control is critical at the system layer. Administrative privileges must be limited. Root or system-level access should require multi-factor authentication and should be tightly monitored. User accounts must be provisioned carefully and reviewed regularly. Patch management is another vital control. Unpatched operating systems and services are a leading cause of system compromise. Organizations must maintain a structured process to assess, prioritize, test, and deploy patches. Configuration management ensures consistency across environments. It uses baselines, automated tools, and secure deployment procedures to prevent drift, reduce errors, and support compliance. Effective system layer security ensures that higher layers like applications and data rest on a solid, secure foundation. Without proper system layer controls, even the best applications can be undermined. For more cyber content and books, please visit cyber.me. You'll find bestseller books, training tools, and resources tailored specifically for cybersecurity professionals. Also explore additional CISSP learning resources and Prepcast episodes at baremetalcyber.com. Let's now explore the application layer. This layer is where users interact with systems and where data is entered, processed, and displayed. It includes everything from web apps and mobile apps to SaaS platforms and business applications. The application layer is one of the most targeted layers in cybersecurity. Threats here include SQL injection, cross-site scripting, insecure direct object references, broken access control, and data exposure. Security controls must begin with secure coding practices. Developers must follow frameworks and standards such as OWASP, which define best practices for preventing common vulnerabilities. Input validation is one of the most important defenses. Any user-supplied input must be treated as untrusted and validated for type, length, format, and expected content. This prevents injection attacks and buffer overflows. Authentication and session management are critical. Applications should use multi-factor authentication, secure cookies, and time-limited sessions. Passwords must be hashed and stored securely. Web application firewalls, or WAFs, help detect and block malicious input at the perimeter. They inspect traffic for known attack patterns and help shield applications from common exploits. Regular application testing is required. This includes static code analysis, dynamic testing, penetration testing, and vulnerability scanning. These practices identify weaknesses before attackers can exploit them. By securing the application layer, organizations protect the data that users see and interact with directly. Application layer security builds user trust, supports regulatory compliance, and prevents data breaches. Let's now look at how to continuously improve security across architecture layers. Threats evolve, business requirements change, technology advances. That means security practices must evolve too. Policies and controls must be updated regularly. Security teams should review architecture designs, test for new vulnerabilities, and apply lessons learned from incidents. Cross-functional collaboration is essential. Network engineers, system administrators, application developers, and security teams must work together to ensure layered defenses are implemented and maintained. Audits and assessments should span across layers. For example, verify that physical protections exist for critical hardware, that system configurations match policy, and that application vulnerabilities are identified and remediated. Training is a key enabler of success. Every team must understand their role in layered defense. Developers must learn secure coding, admins must master hardening practices, network engineers must know how to apply segmentation and filtering, users must understand basic security hygiene. Finally, proactive strategies ensure resilience. This includes adopting zero-trust principles, using microsegmentation, applying behavior analytics, and integrating automation across layers to detect and respond to threats faster. Thank you for tuning in to the CISSP Prepcast by Bare Metal Cyber. Visit baremetalcyber.com for additional episodes, comprehensive CISSP study materials, and personalized certification support. Strengthen your understanding of architecture layers and will consistently support your journey towards CISSP certification success.